Welcome to Axiom. Today, we're diving into a question that seems simple, yet hides a profound truth beneath it. Why do computers use only 0 and 1? Think about it. The most complex machines in the universe. Artificial intelligences diagnosing diseases, supercomputers mapping galaxies, and that little magical device you're watching this video on right now. All of them are built upon just two numbers, 0 and 1. Isn't that strange? Our alphabet has dozens of letters. Our music has many notes. Nature has millions of colors. So why would our most advanced invention limit itself to just two choices? Was it the laziness of engineers? Or is there, hidden in this binary choice, a fundamental truth that reaches deep into the nature of reality itself? To understand the origin of this language, we must go deeper, not into mathematics, but into physics. At the heart of every computer, beneath all the code and programs, flows only one thing: electricity. And electricity, in its purest and most honest form, has only two states. It exists or it doesn't. Just like the light switch in your room, it's on or off. There's no such thing as slightly on or a little bit off. It's absolute. This clarity, this binary certainty, is the very foundation of the digital universe. In the world of computers, there's no room for maybe, perhaps, or approximately. The system must be reliable. Imagine if we tried to use 10 different voltage levels, 0, 1, 2, 3, and so on. Even the tiniest fluctuation, the smallest interference, could turn a signal that should be 3 into a 4. It would be chaos. But the difference between exists, 1, and does not exist, 0, is so distinct that the chance of error is nearly 0. The system never hesitates. It knows. Reliability is born from simplicity. These microscopic on-off switches that make all this possible are called transistors. A single processor chip, no bigger than your thumbnail, contains billions of them, each opening and closing billions of times per second, saying only yes or no. Inside each transistor, these yes and no states are nothing but electrons either flowing or not flowing. If electricity flows, it's a 1. If it doesn't, it's a 0. Each one is incredibly simple on its own. But together, these billions of switches form a vast symphony, proving that complexity arises from the deepest simplicity. So how does this binary system describe our world? We humans are used to the decimal system because we have 10 fingers. We perceive the world in tens. But a computer has only 2 fingers: existence and absence. That's why their language is binary. But how can 2 simple numbers describe this entire video, the color red, or even the letter A? The answer lies in agreements, dictionaries. Just as we've agreed that the symbol A represents a certain sound, computers have their own agreements. They've decided, if we see this pattern of on-off signals, say 0, 1, 0, 0, 0, 0, 0, 1, we'll call that the letter A. If we see this long sequence, that'll represent one blue pixel in an image. If we hear this sequence, that's the sound of a piano's C note. Our entire digital world, every letter, every color, every sound, every thought, is built on this enormous translation contract made of ones and zeros. But maybe this isn't just the language of technology. Maybe it's the language of the universe itself. Is this really only about engineering? Or could it be that we didn't invent this system? We discovered it? Because 0 and 1, absence and existence, are the oldest and most fundamental dualities of all: being and nothingness, light and darkness, order and chaos, reality and illusion, life and death. All of philosophy, all mythology has been written in the tension between these opposites. Maybe computers are so powerful not because they are clever machines, but because, without realizing it, they're copying the deepest principle of the universe. Could the universe itself be a vast computational system? Its fundamental code written, just like ours, in existence and non-existence? Perhaps we are both the product and the interpreters of this cosmic binary code. But will this empire of yes or no last forever? Is binary thinking our destiny? Maybe not, because on the horizon, a new revolution is emerging: quantum computing. Our current computers are built on certainty. Something is either 0 or 1. But the quantum world is a realm of uncertainties and probabilities. Quantum computers use qubits, and unlike classical bits, a qubit can be both 0 and 1 at the same time. We call this superposition. It allows quantum computers to perform calculations in seconds that would take classical computers centuries. It means both existing and not existing, both open and closed, both yes and no. This isn't just a technological revolution, it's a philosophical one. It could change not only how we solve problems, but how we understand reality itself. Maybe the language of the universe isn't binary, but quantum. In the end, computers use 0 and 1 because it's the simplest, clearest, and most reliable language the physical world allows. It's the language of electricity, existence, and absence. But perhaps that simplicity is not just a technical choice. It's a truth of existence itself. Maybe simplicity is the hidden key behind every complex system. So what do you think? Are 0 and 1 merely a clever engineering trick? Or are they a reflection of the universe's own code, its own philosophy? Is reality binary or quantum? Share your thoughts in the comments. And for more science, technology, and philosophy, don't forget to subscribe to the Axiom.